I'm Anil Kumar, and here is a communication question on periodic sinusoidal functions. The question is, how does the graph of y equals to a sine bx changes when a is replaced by its opposite and part b is replaced by its opposite? You can pause the video, answer the question, and then look into my suggestions, right? So what I will do here is, I'll just sketch one sine function and then discuss further with you. Meanwhile, you can think about the answer, write down your answer, and then we'll just compare. Okay, so this is y equals to sine, we should say y equals to a sine bx, let us say. So this is the graph of my function, which I'm saying is y equals to a sine bx. Okay, so in that case, what do we have? So the x-axis has got x as independent variable, y is my dependent variable. When I say a, it means the amplitude of the sine wave is a. Alright, so it goes from minus a to a. And when I say b here, that means the time period is 2 pi by b, right? So that is how this wave is actually representing the equation, correct? Now let us look into the equation. Part A is that when I replace A with its opposite, right? So that means we are changing A value to opposite. I'll consider this to be minus A. Then what happens, right? And when I say when B is replaced by its opposite, then in this part I will think about when B is replaced by minus B, what happens, correct? Okay, so let me write down or show it on the graph what really happens for both the cases. So in this particular case, the case could be, so let me sketch these graphs. A replaced by minus A. What happens really is when I write this equation as, let me write down again, the same equation, which is y equals to minus of A sine bx, right? Then minus makes y values negative of what they were. So the graph actually gets reflected on the x-axis. So the graph becomes like this. So that is what you expect when you replace a with minus a. You get the point, right? So in this particular case, the effect of a being replaced by minus a is reflection on x-axis. So that is the effect. Well, if originally the value was negative, then it was like this, it changes to that position, correct? So either way, the graph is reflected on the x-axis. I hope you get the idea, right? So that is the effect of minus a. But what really happens when you do minus b? Can you tell me that? Well, the original graph, let me just sketch with the dotted line here now. And this is my original graph. What happens when I do minus b? That means I'm going to write this equation again. So my equation now is y is equals to a sine minus bx, right? So you know sine is of minus b is minus sine x. So basically, what really happens is minus b really means reflection on the y-axis, right? So, well, let me extend this so that I can explain you in two different ways. This is a periodic function. So what really happens here is that the function gets reflected on y-axis. So instead of going down this portion, instead of like this, right? So it becomes kind of like this. So what you get is kind of like this. This is what you get when we replace b by minus b, correct? So that is the effect. So we can write this as reflection on y-axis, right? Now some of you can rewrite this equation as y equals to, because minus b could also be written as minus a sine bx. Do you see that? So for some, you could actually go this way also, which looks similar to that, correct? So So in this particular case, when I've taken up that sine function, I could say that it is also reflecting on x-axis. But truly speaking, we are looking for this answer for the particular question. So getting into horizontal, this reflects to horizontal transformation. So it gets reflected on the y-axis. So that is how it should be seen. I hope that helps. Thank you and all the best.